All right, so we said that arrays are array is a collection of values represented by single variable names. Okay, so arrays can be of one dimension or two dimensions. When it's one dimension, they are called vectors. Okay, when it's of two dimension, they are called matrices. So basically, if it's of two dimension, we are looking at it as a matrix where we have rows and columns. So that said, we can say that kindly mute your microphone, unless you want to speak. All right, so we can say that 2, 4, 4, 3, 1, 2. What dimension is this? What dimension of matrix is this? Anyone?
2 dimensions. 2 dimensions.
2 dimensions.
2 dimensions. How will we call this matrix?
So 2 by 3.
2 by 3.
Let me see. Kindly raise your hand so that I identify those speaking. Who is Abayao's phone? iPhone.
Oh, sir, yes, I'm here. Sir, please, it's 2 by 3 matrix.
Kindly rename yourself well then.
All right, okay,
Please,
sir.
let's type our names and index number in the chat for the purposes of attendance.
All right.
Okay. Right. So what's the full name?
It's Abaya Joseph Formula.
Okay, so you're saying it's 2 by 3.
Yes, sir.
All right. Who else? Is it Abdul Latif? Abdul Latif. Do you agree it's 2 by 3?
No, I said it's 3 by 2.
It's 3 by 2. Okay. So, yeah, so this is 3 by 2. Okay. These are the rows and then the column. And we have 3 rows here. 1, 2, and then 3. Okay. And then the columns, we have 1 and 2. So we have 3 rows by 2 columns.
A second letter.
3 rows by 2 columns. Okay. So this matrix is a 3 by 2 matrix. Okay. Then we have vectors. Now the vectors can either be row vectors or column vectors. Okay. Now vectors are in such a way that the values are either the row is of one dimension, okay, or the column is of one dimension. Okay, so if we have a row vector is a type of vector where the type of vector where you have only, or the row having a one dimension or having just one row. Let me put it that way. Okay, so if we take this matrix here, on top here, the 3 by 2 matrix, okay, a row vector can give us 2, 4. 2, 4 can be a row vector where the 2, 4 is looking at this, okay, being the row vector. Another row vector can be 4, 3. Another row vector here can be 1, 2. Okay. Now, if you look at the column vector is also one dimensional. Okay, so if it's one dimensional, you are looking at it based on the column. So let me use a different color, say green. Yeah. So 4, 2, 2 or 4, 3, 2. Okay, so in this form we have 4, 3, and then 2. 4, 3, and 2. So this is considered as a column vector. Okay, so now we are looking at how we can represent this row vector and column vector in our MATLAB. Okay, because going forward we will be looking at examples that deals with how to write this type of vectors and matrices in our program. Okay, because we are doing MATLAB and it's the basics of it. Okay. So let's go to switch to the MATLAB. Okay. And like we said the last time, the first thing you have to do is to switch to the folder you've created. Okay, so I'll switch into the folder. Should have it on desktop. CV 215 part-time, and then save. So I have that folder open. And so we are going to start by giving our matrix or our vectors a name. So we have A equals, so to write a column vector, are we all here? Sorry, to write a row vector, okay, you start with your square brackets and then your value. So if it's 4, leave a space and then 2. Okay, when I press enter, I have it in this form, 4, 2. Okay, similarly, you can leave a comma, use a comma to separate it so that you have it as 4, 2. Are we following?
Yes, sir.
Yes, sir.
Now, if you want to write a row, a column vector, okay, so A is the row vector. If you want to write a column vector, let's say the variable B equals, now to write the column vector, basically is in a transpose form, okay, a transpose form of the row vector. Okay. So to do that, we separate it by the semicolon. Okay. So so this time instead of the comma, we use a semicolon. 4, 3, 3 semicolon, 4, 3, and then maybe 1. Then we introduce our square brackets, and then we have it in column vector. Okay, so you can see that when we do the A, we had it what in this form, in the row form. When we did for the B, we had it what column form. And what is differentiating that is the use of the semicolon here. Okay, the use of the semicolon. So if we go back to the example we are looking at, in case we have it as a matrix. Okay, we said it was 3 by 2. So that 3 by 2, or 2 by 3 rather, we had it as 2 by 3. No, sorry, 3 by 2 was 3 rows and then 2 columns. So we had 4, 2, four, 3, 2, and then maybe 1, 2. So given something like this, if you want to write this as a as a matrix, okay, we start by a variable name. So let's say C. C equals, now using the same concept of whatever we've discussed here, you can see that for the row vector, okay, we have 1, 2, 3. Okay, those are row vectors. So we'll take them in this form, 4, 2. Okay, then we have 3, 2, and then 1, 2. So 4, 2 is one row, 3, 2 is another row, and then 1, 2 is another row. Are you following?
Yes, sir.
Yes, sir.
That is one row. We said with the row, we can separate them with what? A comma, right? Or you can just write them like that, okay? Or separate them with a space. Okay. Now, when it comes to the columns, these are columns. We have 2 columns, right? 2 columns, okay? So to separate each row, okay, we use the semicolon.
Semicolon.
Okay, semicolon. To separate them. So anytime you use the semicolon, it becomes a column. It makes
Vector.
Yes, it makes it a column vector. Okay, or it represents it in a form of columns. So let's come back here to our code. So we introduce our square brackets. We have 4, 2, and then we bring our semicolon, 3, 2, then semicolon, and then 1, 2. Then we introduce our square brackets. And you can see that what our code here is being represented in a form of a 3 by 2 matrix. Okay, in a 3 by 2 matrix. Are we all here?
Yes, sir.
Okay. So for
Yes,
now,
sir.
given any metrics in any dimension, you should know how to write that command in MATLAB to read the matrix, okay, or to read the vector. All right. Now, in terms of arrays, okay, where we are looking at vectors and matrix, we can also find what we call the size of the matrix, the size. Okay, the size. Now the size basically gives you the size of a specific matrix. Okay, so how do we do that? We use what we call the function size. Okay, so size, so maybe I want to find the size of matrix C, okay, which is this one, matrix C. I want to find the size. First, we know that C is what? C is a 3x2 matrix, okay? It's a 3x2 matrix. So when I put C inside the bracket, size C, and I press enter, you realize that it gives me what? 3x2. Can you all see that?
Yes.
It gives 3, 2. Okay, so that is the size of matrix C. Then we did matrix A, right? A column vector. A is a column vector. Okay. So A being a column vector, if we do size of A, what do you think will be the answer? Anyone? This is A. What do you think will be the answer?
It will be 1 by 1, sir.
One by
one.
One by
1 by 2.
one by
1
two.
by 2. 1 by 2.
It will be 1 by 2.
Okay, so it's 1, 2. Okay, so we know A to be this. So the size will be 1, 2. Yeah. All right. What about B? What about B? What will be the size?
1 by 3.
3, 1.
It's going to be 3, 1. It's a column vector.
3, 1.
Okay.
Yeah,
So it's going to be 3, 1 because it's a column vector. So if we do size B, that will give us 3, 1 because it's a column vector. All right, so let's move on. Then another command or another function we have is what we call the length function, length. So if you are asked to find the length of an array, the length of an array, what the length does, it returns the number of, it returns the length of the longest dimension. Okay, it returns the length of the longest dimension. So for instance, we want to find the length of the last one we did is B, right? The length of B. Okay, and we know B to be a column vector. Okay, so the length of B is 3. So it's finding B is what? A column vector, which is what has a size of 3 by 1. Okay, so the length of the largest or the longest dimension is 3. So it will return 3. Are we all here? Are we all following?
Yes, sir.
Okay.
Yes, sir.
So what will be the length of A? We know A to give us a dimension of 1 by 2. What will be the length of A? The length will always return the longest dimension.
2.
2.
That's 2.
Say 2.
Yes. So I'll give us 2. Are we all here?
Yes, sir.
Yes, sir.
Yes, sir.
All right, so let's go back to our material.
Oh, guys, mute your mic. Oh.
Oh.
All right, so let's go on. Okay. Let's talk about what we call the colon operator. By the way, before we look at the colon operator, let me just chip this in. Okay, we have what we call default or predefined variables. Okay, we say variables are names given to entity, okay, in our program. Okay, but by default, there are some predefined variables. Those variables are inbuilt. Okay, one of them is pi. Okay, one of them is pi. So for instance, if I type pi, okay, it gives me what? The value of pi, which is what? 3.1416. Okay, now this pi value is in a dimension we call double. Okay, it's in a double format because it's a numeric value. Okay, now we can, and it's also in what we call the short, or let me just go back to the material and so that we can grasp what I'm saying over here. All right, so this is it. Okay, so the 3.1416 we had is a short type. Okay, we learned from last week that the numeric data types are based on a double precision. Okay, so what we entered for pi was giving us what? 3.1416. Okay, now the short gives us fixed point values with 5 digits. Okay, now you can change that format to long. Okay, now anytime you use long, it gives you 15 digits for double and then 7 digits for single. There is also long E, short E, long J, short J, long engineering, short engineering format, okay, bank format, and so on. Bank format simply looking at when we are talking about currency. Okay, so for any currency you mention, you do point, it's always up to 2 decimal places. Okay, that's how when you go to the supermarket, you see that a product has a price tag of maybe 14.99. Okay, so those particular formats in MATLAB, those numeric formats are known as a bank format. So it gives you the values in terms of 2 decimal places based on the currency, maybe dollars or cents. In our dispensation, it's going to be cedis and pesos. Okay, so it's maybe 14 cedis, 99 pesos, something of that sort. All right, so with what we have here, we can change the format to long. So all we do is say format, and then we say long. Okay, so format long. Now this time when we enter pi, the value of pi now is in 15 digits. Are we here?
Yes, sir.
If we change it to format bank, our value of pi now becomes 2 decimal places. Okay, so based on whatever numeric value you are working with, if you change the format, whatever value you are working with now will be strictly based on the number of digits. Okay, so let's go back to our format short, which is 5 digits, and then work with it. Are we all here?
Yes, sir, we are here.
All right. So, yeah, so I was talking about the predefined variables. Okay, so pi is one of them. Now, you can notice from the examples we've done so far that when we don't assign a value, when I say assign a value, you see that we use the equal to here. Okay, this equal to is called an assignment operator. Joseph, do you have a question? I see your hand up.
Yes, please.
Okay.
Sir, please, I wanted to ask, due to the short,
Yes.
we have 5 digit values.
Yes.
But due to the long, we have more than the 15 you are talking about. I don't know if I am making a mistake, or I don't really know. The 15 digit numbers, when I count, it seems like I'm getting 16.
Really? Let me
Yes,
check
sir.
from here. So
All right, okay.
Oh, it's 15.
Okay.
Yeah, it's 15.
All right.
5. Another 5. Okay, 16.
Okay.
All
All
right.
right, sir.
16.
All right. Okay.
After the decimal, it is 15.
Yeah, after the decimal, but usually it should be together with the decimal. You are counting the digits. Okay. All right, so let's go on. So we're talking about the predefined variables, okay? So pi is one of them, okay? It's predefined, okay? Another one, if you've noticed, is the variable answer, okay? Now, anytime you write a command, for whatever we've written in the command window are commands, okay? Anytime we write a command without assigning it to a variable. So if you look at this, we wrote, this was our command, okay, for the column, the matrix we've written here, and then we assigned it. If I say assign, I'm just saying equal to, okay? We assign this value to our variable C. Okay, that's how come we now have the value of C, okay, as being this. Now, when we came to the size, we didn't assign it to any variable. So what happens is that MATLAB would automatically give us what we call the answer variable, ans variable. Okay, so anytime you write a command without assigning it to a variable, MATLAB automatically gives you the answer variable. Now, what will happen is that if you keep repeating the commands without assigning them a variable, all the commands you keep giving the PC, the MATLAB program, would keep overwriting your answer value. So for instance, at the moment, our answer value is what? 3.1416, because the last command we wrote has to do with what? Pi. And we didn't assign any value to pi. For instance, if I say a, small a is equal to pi, you can see that what? Small a here is now pi. Okay, but if I don't do that, the value of ans will change again. If, for instance, I go and do, let's say, let me look for something we've done. So length B. Okay, now you can see that the value of ans has changed to what? 3, because the length B was going to fetch us or return longest dimension of the vector of the column matrix B, which is 3. So take note of this answer variable, okay, anytime you are using it. So if you want to use, so if we want to actually get the value of B, we can actually give it a name and say length of, say, B equals length into brackets B, capital B, right? So it's giving us what? So you can see a length of B. Now this length of B is a variable name which I've declared, okay? I've defined by myself. So you can see here it's part of the variable names. So instead of the answer being stored in ans, the ans variable, which is predefined and which can be overwritten anytime, I rather give a variable name to it. Now you can see the way I've written the variable name, and you remember the rules we mentioned from last week. I hope you still remember the rules.
Yes, sir.
We don't space them. Okay, if you want to space, you use
Underscore.
only an underscore, no other character or no other symbol. Okay, so take note of that. Okay, to be on a safer side, just write all your variable names together. Now, this is what will happen if I wanted to space it out. So instead of I say length of, and then I do this, I see what is happening. Eventually, the color changes. So you should know that you are making a mistake here. Run to an error, too many input arguments. So it's not expecting this. Okay. So it will give an error. All right. So let's look at the colon operator. So the colon operator is used for creating and manipulating arrays. Okay, it has a powerful feature. Now, the colon is used to separate two numbers. Okay, so MATLAB generates the numbers between them with an increment of 1. Okay, now this is how the colon operator works. For instance, let me just clear what we have here. So for instance, we've been given a scenario. Okay, now let's say the question goes like a list of even numbers from 2 to 10. Are we all here? Or let's say a list of whole numbers from 1 to 5. List of whole numbers from 1 to 5. Okay, so you say let A be list of whole numbers. Pardon my write out. Let me use this instead. So A is a list of whole numbers from 1 to 5. Can we all see it?
Yes, sir.
Okay. So typically on a normal day, we would have said a list of whole numbers from 1 to 5. We would have done, okay, maybe a column vector, and then say, oh, sorry, a row vector, and say A is equal to, let me just do it on the in the command window. So we would have say A is equal to 1, 2, 3, 4, 5. And have something like this. Do we agree? So these are whole numbers from what? 1 to 5. Okay. Now, we have the column matrix, which will say that the column operator, which says that when you have numbers in this form, okay, we use the column matrix in between. So 1 column 5. Let me write it in such a way that we can all appreciate it. And you can see that what is giving us what? The same value, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so if you look at the question very well, we input the first number, which here is 1. Okay, so the one to the left is the first number. The one to the right is the last number. Okay, now this column here shows the increment. Now by default, the increment is by 1. By default, the increment is by 1, okay? So let me rewrite this again so that you see how the increment works. Okay, so we have this. Now, it should have been in this form. So you can see now I'm introducing 2 columns, okay? It should have been like this for us to get this, okay? Where the increment, the one which is in the middle here, is the increment value. Increment value. And by default, it is always 1. So we have 1 here as your first value. So a whole number from 1. So we start from 1 to what? 5. So we end at 5. Okay. And by default, the increment is 1. So this is the same as this, which is also the same as writing this way. Okay, but what if the question is saying from 1 to 500? If you are using the first approach here, that means you'll be doing 1, 2, all the way to what? 500, which is too long. Do we all agree?
Yes, sir.
Yes, sir.
So to do it in a short form, let's go by this approach here, which says A is equal to what? Who can tell us?
1 colon 100.
1 colon 500. Okay.
500.
And that will give us all the numbers from 1 to 500. So A is equal to 1 colon what? 500. And that is giving us, let me clear whatever we have here. So you can see the values. Starting from 1, 2, 3. Okay. All the way to, that's long. All the way to what? 500. Now, when we come to the workspace, you can see it's being represented here. A is what? The value is 1 by what? 500 double. Are we all here?
Yes, sir.
Yes, sir.
Let's take another example. So I'll clear whatever we have here. It's too long. Let's take another example. We want to look at let's be a list of even numbers from 2, no, from let's say 0, from 2, let's use 2 to 20. How can we write this command in MATLAB? Anyone? Oh, sorry. Oh. How can we write this command? Who can guide us? Yes, Musa. Yes, Musa Faisal. Yes, who wants to help us? Anyone?
I want to try.
Okay, Daniel, let's go.
Okay, so it will be 2:2:20, right?
Let's start. Read the question very well, and let's put it in the form of a command.
Let
Let's
be a list of even numbers from 2 to 20.
Okay. So let's go.
So 2. Let me write B is equal to.
Thank you. So you've been told the variable here, which is what?
Yeah. B.
The variable is B. Okay, so let's what? So B is equal to?
Capital B is equal to 2 colon 2 colon 20.
Colon 20. Okay, so why are you saying 2:2:20? Can you break
because
it down?
at first you said the increment was 1. That's why we used 1.
Okay.
So since it's going to be 2, I think you have to use 2 so that it will give you 2 increment.
Okay. So you see our answer. So we are moving from 2 to 20. However, we are saying that's what? Even numbers. So even numbers from 2, we move to 4, to 6, to 8, to 10, all the way to 20. Okay. So sometimes the question or the problem will come and you will not be told that your values are this, and that. Okay. You'll just be given a scenario like this, and then it's up to you to use, with the help of the colon operator, to come up with this this command. Okay, let's do another one. Let's see.
Sir.
Yes.
Sir.
Yes.
So assuming the interval is supposed to be 3, meaning it will be 3 must be at the second side of the like 3. We will have to add 3.
Yes.
Okay.
So for each increment, we are adding 3. Okay. So let's do for odd numbers. So odd numbers from 1 to 20. Who wants to try?
Okay, sir.
Gideon or Prince? Who wants
All right,
to
sir.
Gideon, okay.
Okay, so C
C
is equal to
yeah,
the colon the
brackets.
Yeah. So 1
column 3
column 20.
column 20. Okay, so is it right?
Yes, sir.
Is it right?
Yes, sir.
Are you sure?
Say no.
Who is saying no? We are looking at odd numbers. Yes, who is saying no? Is it Olanyo?
Yes, please.
Okay, Olanyo, so what's your response? What's the right thing?
Say 1 column 2 column 20.
1 column 2 column 20. Okay,
Yes,
we are
please.
looking at odd numbers and we are starting from 1. Okay, so 1 plus 2 will give us what? 3.
3.
Plus 2 again, 5.
5.
Plus 2, 7. Plus 2,
7.
9. All the way.
9.
But Gideon, when we are using an increment of 3, we are going to get 1 plus 3, which will be 4. Plus 3 again, 7. Plus 3, 9. Plus 3, 10. Okay. And these values here are not odd numbers. You get it?
Sir, please, can you come again?
You said we should use an increment of 3. Right?
Yes, sir.
Now, we are looking at odd numbers and we are starting from 1.
Okay.
So if you say the increment should be 3, that means when we start from 1 and we add 3 to it, we'll get 4. When we add 3 to the 4, we'll get 7. Because you said increment of 3. And now from what we've done so far, 4 is not an odd number.
An odd number.
So automatically yours is wrong. So rather we use 2. So that when we start from 1 and we increase by 2, we go to 3. Increase 3 by 2, we go to 5. Increase 5 by 2, 7. And that's order. You see the logic?
Oh, okay.
So,
all right.
Take note of that. Okay. So we change to 2, and then we have 1, 2. So you realize that even though our last number here is 20, okay, it's ending at 19 because 20 is not an odd number. You see that?
Yes, sir.
Yes, sir.
All right. So that is how the colon operator works. Okay. At least we will look at 2 examples with the even number and odd number. Okay. So there are times where a question will come in a form of a plot. Okay, where you are supposed to plot maybe some x-axis by some y values, x values by y values. Okay, and you are given it in this form. So we will just say, okay, your y values are set of even numbers from, let's say, 2 to 20. Okay, so once you see the question like that, set of even numbers from 2 to 20, automatically you should know that they are requiring you to use what? This computation or this command for your y. Okay, for your y. Now, similarly, your increments can also be in a negative form or in a decimal form. Okay, so for instance, I can say d is equal to, maybe I'm moving from 0 to 3. Okay, 0 to 3. However, I want to increase in 0.5. My increment is 0.5. That means that when I start from That means that when I start from 3, my increment, when I start from 0, my increment will be what? 0 what? What's the next value?
0.5.
0.5.
And the next one?
1.
1.
And
Then 1.5.
1.5.
Then 2.
2.
In that order until I get to what? 3. Okay, so you can see what we have here. Okay. Now, why do we have the values in 5 digits? Who can tell us shortly? Why do we have the values in 5 digits?
There,
Yes, Latif.
it might be because we are dealing in decimals.
Oh, we just talked about this not long ago. Because we are using the format short. Do you remember?
Yes, sir.
The format short
Yes, sir.
is giving us 5 digits. So if we use the format bank
We get 2.
and we use our value again, you can see that what is now in 2 decimal places. Okay. All right. Now, another thing too is that the value can be in decreasing format. Okay, so we have our 0.5. So we can have it decrease in decreasing form, where the incremental value will now be a negative value. So for instance, if we say E, okay, if it's in a negative value, most often your first value, which in this case for like the D is 0. Now you should start, the highest value should be the first value and the lowest value. The last value should be the lower value. Okay, so you are decreasing from maybe 3 to 0. Okay, so what I'm saying is this. So E is equal to 3 colon 0.5 colon 0. Okay, now what is happening here? Okay, we said we are moving from 3 to 0 and we are increasing it in 0.5, which doesn't make sense because from 3 to 0 we are decreasing. So we can't have an increment value there when we claim we are decreasing from 3 to 0. Okay, we are sending from 3 to 0. So rather, our value in the middle should be a negative value. Okay, if it's a negative value, it starts from what? 3 goes to 2.5, 2, 1.5, 1, 0.5, and then 0. So you can see that is the opposite of B, where we are moving from 0 to 3 with an increment of 0.5. However, with E, we are moving from 3 to 0 with a decrement value of minus 0.5. Are we here? Are we following the logic? Yes.
Yes, sir.
Yes, sir.
Okay. All right. Any questions so far? Any question? You are still looking at the basics. right, so let's talk about one more thing before we call it a day. Okay, so we have what we call the character string. Okay, character string. Now, if you remember from last week when we talked about the data types, we mentioned the numeric data type and then the character data type. We said the character data type are made up of characters, okay, which are digits from 0 to 9, alphabets from A to Z, where we know that the capital A is not the same as small a. Okay, and then we have the symbols. So when we look on our keyboard, we have a perfect description of characters, where we have asterisk, question mark, dollar sign. These are all characters. Okay, and when we look at the numbers are from 0 to 9. These are all characters. Okay, so a character string or strings are basically combination of characters. Okay, so your name can be, or your name is a string. Okay, your name, Daniel Kuma, is a string. Even the space between the name, Daniel and Kuma, that space there is considered as a character. Okay, so it is a string. Okay, so you can see here, Miles Davis, okay, with a space here is considered as what? A string. Why? Because it has what? A combination of characters. Now, one thing you should take note of is that anytime you are writing characters, characters are enclosed in single quotation marks. Characters are always enclosed in single quotation marks. Okay. Then also we can concatenate them. If we say concatenate, we are talking about putting two strings or characters together. Okay, so Daniel is one string, Kuma is another string. When we concatenate it, we get Daniel Kuma. Are you following?
Yes, sir.
Okay. All right. So let's
Yes,
out. Let me just talk about. Then there are some descriptions here, some functions here. Okay, which works with these characters. So all that we looked at earlier has to do with the number data type, the numeric data type. Okay, now we are looking at the character data type. So with the characters too, you can find the length. So the length has to do with the number of characters within the string. Okay, so the name Daniel. Daniel has 6 characters, D-A-N-I-E-L. Okay, so anytime you use length, it will fetch you the number of characters within the string. Then we have string comp to compare two strings. Okay, it will return 1. It will return true, which is 1. Okay, if the strings are the same. Okay, so string 1 and string 2. If string 1 is Daniel and string 2 is also Daniel. Okay, when you use this function, string comp, okay, and you put Daniel here, string 1, and put Daniel here again, it will give you, or it will return true, which is 1. Okay, a Boolean value, we call them Boolean values, true or false. So 1 is true, 0 is false. Okay, but if you put S1 as Daniel and S2 as Kuma, those two strings are not the same. If you are saying they are the same, we are looking at them character by character. Okay, capital letter the same as capital letter, okay, and so on. If not, it is false. Then you can convert also from string to number. You can convert from number to string. Okay, you can do what we call replace a string. Okay, find a string, convert a string to lowercase, convert a string to uppercase. Okay, these are all properties with string. Okay. Next week we'll look at the mathematical operators before we go on our Christmas break. Okay. So let's try out some examples in MATLAB regarding the use of strings, which we need to understand really well, because some of the things we'll be doing after the Christmas break, taking examples or problems and be writing programs. This time around, we'll not be writing commands. We'll be writing what we call scripts, okay, which are a full set of instructions to write or to program something or to solve a particular problem. Okay. All right, so let's look at some, let me just clear everything here, clear the workspace as well. Okay. So let's use the Daniel Kuma example. Okay, so we put a variable there and say first name. Now, first name is equal to Daniel. Now, Daniel is a string, okay, which is a combination of characters. And like I said, we always enclose characters or strings in a single quote. So you can see my single quote. And then I type the name Daniel there. So you see that this here is different. Okay, once I put it in a single quote, the color changes. Okay. Then the surname is what? Kuma. Okay. Now I want a space between the Daniel and the Kuma. So maybe I have to rewrite the Daniel name again. Okay, and put a space here before the closing of the. Okay. So I introduce another variable, and this variable, this time I'll say full name. So full name equals, okay, square brackets. So the first one is first name, comma, or space, surname. So what does that give us? It gives us what? Daniel Kuma. Okay. So we realize here that the first name, which is this one, is Daniel. And then the surname is Kuma. Okay. But first we have what? Written them here. You get it?
Yes, sir.
So what you've done here is called concatenation. Concatenation. Okay. So anytime you are writing a character, take note, this single quote. Okay. Now, just a quick one before we end. These characters, like I said, numbers 0 to 9 are also characters. So for instance, if I say A is equal to 5, okay, it's not the same as me saying, let me say B is equal to 5 in a single quote. You see the difference?
Yes.
Okay. So the A is equal to 5. This 5 here It's a numeric value. Numeric value, so you can use it for computation. Okay, so you can have an equation A plus 3. Okay, you can have A plus 3, where in this case it will substitute your A as what? 5 plus 3, which will give you 8. Okay, it's numeric. However, B equal to 5. This 5 here is a character. It's no longer a numeric value. It's a character value. Okay, so you can't use it for computation. This 5 here is a character. You can't use it for computation because of what? The single quotes around it. You can't use it for computation. Okay, all that you can use it, that's to use it as string. Okay, so to concatenate it with another character and all that, but you can't use it as, you can't say B plus 3. Okay, where we know B to be what? The character 5 plus 3. This will not give us 8. Okay, for instance, let's just do it here and see what we'll get. B plus 3. Okay, what do we get? 56.
Yes.
Okay, that is telling us that this B, this 5 here, I'm sure is giving us the ASCII value for 5. The ASCII value of 5. Let me see if I can get my ASCII table so that we can just be sure that is what it's exactly doing. It's here. Anyone with a table can help us check. So ASCII value of 5 is 53. The decimal value is 53. ASCII value of 5, of the character 5. So you can see the ASCII value of the character 5. So that 5 there is not a number, it's a character. So its decimal value is what? 53. So it's doing what? 53 plus what? 3. Okay, and that's giving us 56. Are we here?
Yes, sir.
Okay, so these are some of the basics in MATLAB that we should really pay attention to. These are the basic things in MATLAB we should pay attention to. Okay, you need to understand and appreciate this basic concept so that when we start writing programs or writing scripts, you can actually understand the scripts that we are writing. These are the basics. Okay. Going forward, you'll be writing scripts in terms of syntax. So if you don't follow the syntax, if you don't follow the rule, you get it wrong. But you have to understand this basic approach, and then we can add the syntax to it. Any question? Any question? Any question?
Yeah, sir. So Sir, can you please scroll up for me a bit? So, the first slide you wrote a first name, then it got to then you said Daniel. Then I realized that you wrote another first name again after the surname.
Okay, so this is what happened. So look at it very well. So I wrote first name Daniel. Okay.
Yeah.
I wrote first name Daniel again, but this time I gave a space here. Do you see it?
Yes, sir. Yes, I've seen. Yes, sir. I've seen it.
I did that so that when I want the full name, it can give me a space before the comma. If I didn't do it that way, it will just be Daniel Kuma together without the space.
Okay. Okay.
So I have to put the space here. Okay. In our next meeting, we'll look at we'll look at the script. When we write the script, we'll look at how to write an input statement and output statement. Okay. And when you appreciate some of this, so in that context, you'll be mixing the numeric values and the character values, and then you appreciate some of these things.
All right, sir.
Any other question? Any other question?
Oh, please.